This is no ordinary ship.
It's one of the biggest in the world.
To carry some of the largest sea cargoes ever, it does what most ships are designed to avoid at all costs.
It's really amazing to see something this big immerse itself almost completely underwater and then come up again carrying something huge.
It's a bit of a game changer. It's like kind of a combo cargo ship and submarine.
The GPO Amethyst is one of a prestigious superclass of ships known as semi-submersible heavy lifters.
To be a captain on this vessel is actually a great honor.
From the outside, it's impossible to see the feats of engineering that give the Amethyst its incredible capability.
So a lot of factors can go wrong, and we should be ready for any of these.
The only way to reveal its secrets is to take this super ship apart and uncover what's going on inside. Today, the Amethyst is en route to the Gulf of Mexico, where it will attempt to load up 2 giant decommissioned oil rigs bound for Oman. At the helm is Captain Yevgeny Nikityuk, who's been in the ocean-going heavy lifting business for 11 years. The next few days will see his ship tested by not only some of the biggest cargo on the seas, but also by weather that pushes them to the brink of disaster.
And we have 7 squalls appears, with wind speed up to 55 knots.
In recent years, global industries like oil and gas have demanded ever heavier cargo to be transported across the globe. Single items can weigh up to 50,000 tons, and that creates a real problem.
The weights of these things is just absolutely mind-boggling. Just imagine trying to move that from A to B. It'd become almost impossible. Things like road and rail, you just can't move a modern oil rig like that. And the old solution of dragging them using tugs just wasn't cutting it. So an entirely new approach was needed.
The only viable solution is to transport these exceptional cargoes by sea. But to do that requires an exceptional ship. Enter the Amethyst, one of heavyweight ocean transportation's most advanced vessels.
This is a class of huge heavy lift ships, and they're just awesome in scale. They're enormous, and they can lift things which are so heavy you just can't lift and transport them by any other means.
I find this type of shipping very, very interesting. Each project, each cargo is totally different. We are loading and discharging cargo all over the world. And it's just an amazing type of shipping.
This ship's deck is an incredible 600 feet long and 158 feet wide. It's so big that no less than 16 Statues of Liberty would fit onto it. The deck can also accommodate both of these enormous oil rigs that tower over 200 feet above sea level.
Imagine trying to move a massive oil rig weighing tens of thousands of tons. And worse than that, it's not at all hydrodynamic. It's not got a beautiful, sleek hull like a boat. It's basically a massive square. So moving these things had become more or less impossible.
As the Amethyst approaches the rigs, the 26-strong crew prepare the deck for the colossal cargo.
So now they are putting the stagings down on the main deck.
The rigs have a combined weight of 25,000 tons. And that presents a fundamental engineering challenge.
Now, the most obvious problem of carrying such heavy cargo on the deck of a ship is the strength of the deck itself.
The Amethyst has a very, very, very long deck. So when it tries to pick up a load, if the load was very heavy and just concentrated right in the center of the deck, it might try to taco the whole ship. The front of the ship would hit the back of the ship.
A deck of very thick steel would stop it from caving in, but it would also make the ship far too heavy. In fact, it has a very thin deck.
The thickness of the steel is tiny compared to the area. Without any additional stiffening, it's going to buckle like a piece of paper under these loads.
The solution comes from dry land, from inside skyscrapers. The deck is only an inch thick. But underneath it, there's a lattice structure connecting it to a second thin deck. The lattice is comprised of very specifically shaped steel beams. Their cross-section is like a capital I, just like the I-beams that hold up skyscrapers. Even when immense force presses down on them, the shape should prevent any distortion and protect the thin top skin of the deck.
And that's going to increase the stiffness without increasing the weight very much, because at the end of the day, this vessel needs to float.
The next problem is how to distribute the load across the deck.
It's really important that the cargo deck remains flat, because if it bends slightly and part of the deck is higher than another part of the deck, that load will all sit on the highest part of the deck momentarily, which could break the ship.
At a shipyard in Kaohsiung, Taiwan, GPO are building 2 more heavy lifters with the exact same design as the Amethyst. And they're in the midst of constructing the super strong ultra-flat decks. Giant piles of steel plates are being prepared. "154 of them need to be fixed together. That's 1.5 miles of seams to be precision welded."
Welding steel plate is very challenging, but it's necessary for a ship like this.
We use carbon dioxide arc welding to make the joints, because it's fast and gives a really smooth finish.
Once the welding's complete, the deck is inspected.
Yeah, this deck should be extremely flat for the cargo operation.
Shipbuilding doesn't usually involve measurements in tenths of inches, but for these ships, it's vital.
Acceptable limit for the deck is a 3.54 milli for our deck. Now it's absolutely okay.
These vessels will be complete in roughly a year's time. Back in the Gulf of Mexico, Yevgeny is racing to rendezvous with the cargo.
Other port. 090, steady.
The Amethyst must have an extraordinarily powerful engine system to maximize its speed. The question is, what? With a total length of 738 feet, a breadth of 158 feet, and a height of 20 stories, the Amethyst is vast. It needs to be to successfully pick up its consignment, these two massive decommissioned oil rigs.
Там вообще нет опций, там только safety коридор. Все.
Captain Yevgeny checks his radar.
We're just trying to locate where the first rig is now.
He's closing in on the loading location near New Orleans.
It's on the starboard propulsion, on the port propulsion. Port 20.
Once the rigs are loaded, the Amethyst needs to carry them more than 13,000 miles to Oman as fast as possible.
These vessels are operating, transporting very expensive drilling rigs, for example, and the drilling rigs, very expensive day rate. So time is very important.
It's crucial that nothing goes wrong with the propulsion system, so Chief Engineer Konstantin has a computer system to monitor it.
My role here is I'm responsible for all equipment. Что вы там крутите? У нас съемки идут. Ну, на одном посмотрите, на остальных не надо.
There's only one choice for the main engines. Diesel power remains the standard. And for a ship this size, the engines need to be gigantic. One is not enough, so it has a pair on either side.
This is our main diesel engine. For this ship, we have 4, like this one.
Each engine is around 9,600 horsepower. That's the equivalent of 12 Ferrari V12 engines. You know, these are really, really powerful engines.
Extreme power means extreme weight. Each engine weighs 132 tons. The 4 of them together are heavier than a jumbo jet. But curiously, these engines are nowhere near the propellers.
In most ships powered by diesel engines, the engine is connected through a gearbox to the propeller shaft. But on this ship, the engines aren't physically connected to the propellers.
The engine's massive size means the only place they can fit is at the bow. But that means a 540-foot-long drive shaft, connecting the engines to the propellers, which can't be done.
One issue with having a 540-foot-long drive shaft would be that it would need to be supported all along that length, and that would have to have bearings and other kinds of equipment. You'd have to have access to all those things, and so that would take up a lot of space below the deck.
Under the bridge and at the bow, the only place there's room for them, lie the beating heart of the ship, the Amethyst's engines. To get the power to the propellers, they drive electric generators. Then, cables carry the power the entire length of the ship to electric motors at the stern, which directly drive the propellers. No long drive shaft required. It's an elegant solution, but it does mean the electric motors at the stern need to be exceptionally large as well.
One of our propulsion room, we have big motors with power 4,000 kilowatts.
The most powerful electric motor in most people's house is probably in their washing machine. And each of the motors on Amethyst's propeller shafts is 5,000 times more powerful than that.
That kind of electric power gives the Amethyst the ultimate spin cycle. And to generate sufficient thrust, the propellers are 18 feet tall. But what's really clever is the mechanics hidden inside them, which means they have to be installed with extreme precision. In Taiwan, there's a rare chance to see these propellers above the water. They're installing the starboard prop on the Amethyst's sister ship, the Emerald.
This is a job that needs an engineer. It's so precise they have to sign off the measurements before we can do anything.
The blades are made from a copper, nickel, and aluminum alloy. They're designed to cut through the water with exceptional efficiency.
We can sail up to 16 knots, which is more than normal for a ship like this.
It's the fastest ship in its class. But it's what's inside the propeller shafts that makes the Amethyst's propulsion system remarkable. Each propeller has 4 blades. Normally, the system is solid. Not on the Amethyst. Inside each shaft is an oil-filled hydraulic piston. When these move, they alter the angle of the blades. This means they can swivel or be feathered to change their pitch, and therefore the thrust they produce. They can also swivel into reverse, so the shaft spins the same way to go forwards or backwards. And when not needed, they have a zero drag position.
If the one propeller shall not be used, it will fold and make a minimum resistance. The ship can keep good speed with only one propeller.
Time is money. And in heavy industry, where an oil rig rents for upwards of $100,000 a day, the Amethyst has to be reliable, even if the worst happens. With 4 diesel engines and 4 electric motors, even if there are multiple breakdowns, both propellers keep turning.
This ship has the ability to automatically hold her heading in position in good weather, and she can keep doing that even if a component fails. That's why she has to have 2 motors per shaft in case one breaks.
The Amethyst's propulsion system is a triumph. The ship can cruise for 25,000 miles without needing to fill up. That's all the way around the planet. Right now, Yevgeny is anxious to meet his cargo on time. But cruising at high speed in a ship this large and heavy makes one task particularly difficult: bringing it to a stop.
It has huge amounts of momentum pushing it forward. Now, the only way really to make that stop is to have a force in the opposite direction acting upon that ship.
"8 a.m. Captain Yevgeny is motoring at full speed to the location where the Amethyst is about to load one of its most challenging cargoes yet. 2 scrap oil rigs that it will ship to Oman.
Речь, Captain. Мы только начинаем разгоняться.
With one of the biggest ships on the oceans, even the simplest of operations, like coming to a stop, has hidden complexities. At sea, you can't just hit the brakes. This ship weighs 31,000 tons empty. Stopping is like stopping a Formula One car that's traveling at over 700,000 miles an hour.
If you have a car on land and you hit the brakes, the friction between the tires and the road will quickly bring the car to a stop. But the friction against the hull of the Amethyst is very small. And even if you turn the propellers off, that thing will keep going for a very long time.
In open water, the high-tech propellers can switch to reverse thrust while spinning in the same direction. That's 8,000 kilowatts, all used to force water backwards. It can stop the ship dead in 500 yards.
Prepare starboard anchor.
Time to drop anchor.
Please report when be ready.
Meet Alex. He's the loadmaster and has over 25 years' experience supervising some of the most complex ocean cargo operations on the planet. He's heading out to the Amethyst to plan the detailed execution of the load.
The loading can be in 3 days. But we need good weather.
Now on board, Alex studies the weather forecast with the captain. It is not looking good.
Big question mark. The direction the weather is going to, we don't like, because actually the window is closing.
The forecast become less friendly for loading operation itself, yeah. But overlook is not promising. It's not promising at all. Yeah.
They need inch-perfect positioning to load the oil rigs. If there's bad weather, it'll mean delays. If there's a storm, they won't be able to load at all. And there's one on the horizon. The question is, when will it hit? The whole mission hangs in the balance. Even in good weather, it is extremely difficult for the Amethyst to hold its position in the open sea.
A ship afloat can move in what we call 6 degrees of freedom. It can slide forward and backward, left and right, up and down, and it can also turn around each of those 3 axes, rolling, pitching, and yawing.
The Amethyst has special hinged rudders, which gives it a much smaller turning circle than many other ships of its size. In Taiwan, they're installing them on the new ship, and it needs to be done with incredible accuracy.
We need to precisely align the center line from top to bottom to make sure the rudder base is balanced when we install it.
Fitting the rudders is not easy in Taiwan's tropical high temperatures. In the heat of the day, the metal expands, which could mean the team don't put the rudder in the right place. An inch off could compromise the ship's maneuverability. So they use a simple, if inconvenient, trick.
We have to do it at night to ensure we eliminate any chance of miscalculations.
Even though the cargoes are enormous, loading them aboard the Amethyst will require extremely accurate maneuvering. Fancy rudders alone are not enough. Deep below the waterline, near the very bottom of the vessel, there are several curious shafts that traverse the ship. Inside, there are thrusters, extra side-on propellers, that can force water out of the shafts in controlled bursts.
The forces required to maintain its position precisely are just enormous. And that's why her bow and stern thrusters are huge. They can generate very large amounts of thrust very quickly when they're needed and stop again very quickly when they're not.
There are 4 thrusters, 2 at the bow and 2 at the stern.
The 4 thrusters now in operational condition, number 2 and 1 bow thrusters, and number 3 and 4 stern thrusters. So we can swing the vessel in desired direction how we need to.
With these thrusters, the Amethyst can move sideways in tiny increments, as well as forward and reverse. Like the main propellers, they can change the pitch of their blades to control the thrust they're delivering. They're part of what's called a dynamic positioning system. But although it enables incredible control of the ship, it can do nothing to control weather. Either wind speed or wave height could halt the mission.
Yeah, to load these 2 rigs, we need wind less than 10 knots, and the sea stayed less than half a meter. If it's above these limits, then we cannot load because it's not safe. We can damage the vessel, the cargo, and most important, we also can harm our crew during loading.
It's 6 p.m. off New Orleans, and Alex checks the forecast. He discovers his weather window is shrinking. The storm is heading their way, and the crew are suddenly concerned.
We have 7 squalls appears with wind speed up to 55 knots. Major swell coming from the south in the area.
The Amethyst is waiting to load 2 oil rigs with a combined weight of 25,000 tons. But overnight, the weather takes a turn for the worse.
We have 7 squalls appears with wind speed up to 55 knots.
A force 8 gale is now blowing. With gusts more than 5 times the wind speed they can safely load in, the entire operation is in jeopardy. If there's no window in this violent storm, they might have to reschedule the operation.
This is a good example of the adverse weather can change gradually just within seconds.
They resort to engine power to try to stop the Amethyst from pulling anchor.
But the anchor is holding well, and we are just confident that we are safe at the moment. So we just get ready in all respect, just in case.
After an anxious wait, the lashing rain subsides, leaving just high winds. Yevgeny needs to know how the rigs are doing. If either is in trouble, the loading will have to stop.
They are also compensating the wind effect in the area. So hopefully they are okay.
Next morning, the wind dies down. But as the crew wait for the swell to return to safe limits, new information suddenly comes in about how deep the rigs are sitting in the water. They're lower than expected. This is a crisis for the Amethyst because of the highly unusual way she's going to load the rigs. 25,000 tons of awkwardly shaped steel looks impossible to heave onto a deck. The GPO engineers had to defy shipbuilding logic.
The main deck is going underwater. We are submerging it.
The way the Amethyst will load the oil rigs is to deliberately submerge its deck beneath them and then refloat to lift them out of the water. The Amethyst is known as a semi-submersible because it only partially sinks.
There's something really impressive about seeing something just so massive submerge itself almost completely underwater and then come up again. Just the scale of these things is mind-blowing.
I find it absolutely incredible. So a ship that can sink itself in a controlled manner sort of defies science.
So how do the Amethyst designers achieve a feat that challenges the fundamentals of ship design? The answer is hidden under the deck. Below the steel lattice, there's no cargo hold, no cabins. The ship's entire hull is made of ballast tanks. When water is pumped into them, it reduces the ship's displacement, and the ship gradually begins to sink below the waterline.
Не, у тебя он идет первый крюк сверху, на этот, а второй крюк на ступеньку любую.
The Amethyst is ready to submerge, but the news that the oil rigs are sitting lower than expected in the water changes everything. The ship will have to be lowered further than planned to float the rigs over the deck. And there's a bigger problem that needs urgent attention. When submerged, guideposts welded to the deck need to be visible above the water to show the exact spot the rigs must align to.
Значит, на этот H-beam, вот тогда, как говорили, делайте прорезь в трубе, надеваете.
With the ship deeper, these guideposts will be completely invisible.
Original design guidepost is 7 meters, so the guidepost should be extended by 2 meters height to be visible while the floating cargo will be over the deck.
The whole operation will be called off if the crew can't modify these guideposts.
The option is to weld the special antenna up to the 2 meters high.
Extending the guideposts should enable the operation to continue. The crew have to work fast. They don't know how long the weather window will hold. Finally, the captain is satisfied. The huge deck area is now ready to receive the 2 giant cargoes, and the operation can begin. It will take about 6 hours. The hull of the Amethyst can fit 160,000 cubic yards of water, enough to fill 49 Olympic swimming pools and create a potential danger.
As the ship moved slightly in the waves, all that ballast water would slosh from one side to the other or from one end to the other, and the ship would roll over, no doubt about it. There's a very simple solution to avoiding capsizing your ship, which is to break the ship up into a large number of ballast tanks. Divide the sloshing surface up into as many pieces as you can.
The hull is split into a total of 76 ballast tanks, laid out in 3 layers. This allows the crew to regulate exactly which parts of the hull are emptied, so that the ship is always kept stable.
It's very complicated. A lot of ballasting.
Ballasting stuff.
Inside the bridge, the crew begin the submerge.
This is the main brain for the cargo operation, so this is actually the system which is vessel designed for.
The ship's 95,000 square foot deck starts to sink down 30 feet.
This is the physical process of taking the water into the designated ballast tanks, how it is calculated in order the vessel to get the positive stability all the time for the cargo operation.
By early morning, the ship's hull is successfully submerged. But this is when it's at its most vulnerable.
I can't say that we are just not nervous. We are.
Partially submerged, the Amethyst waits for the first of its monumental cargoes to be floated over it. The next part of the operation is the most dangerous, bringing the cargo into physical contact with the Amethyst. This rig alone weighs 13,500 tons, so the Amethyst's crew must make sure the ship doesn't sink altogether.
All the personnel must be very vigilant all the time, and especially the guys who is operating the particular system, including the guys who is controlling this.
When the ship's ballasted down for loading, she's in a very vulnerable position. It doesn't take very much flooding before she's at serious risk of sinking.
The ship now has roughly 100,000 tons of water inside its hull. All that's stopping it plunging further are the parts above sea level. Where they break the water line is known as the water plane area.
When Amethyst is ballasted up in her transport configuration, she has a huge water plane area, and that gives her enormous stability. But when she's ballasted down in the loading configuration, her water plane is tiny.
The bridge holds up the bow of the ship. And more critically, these two giant towers, the stern.
These two towers and the forward part of the ship is actually keeping the vessel horizontal and still floating. Each of these towers have ballast tanks of about 3,370 tons.
As long as they're kept above sea level, the water plane area will be large enough to stop the ship diving to the bottom of the ocean. At last, with the weather holding, the first rig can be loaded. Alex instructs 3 tugboats to gently pull the rig towards the Amethyst. The closer they get, the higher the risk.
There's not a lot of ship above the water. She doesn't have a lot of spare buoyancy, and there are tugs and there is a heavy object moving around her. There's a very high risk of collision.
The corners of the load now need to be tied to the ship, so it can be carefully winched in to line up with the guideposts.
So the first line connected to Amethyst, tower bow. Line number 1.
With 4 ropes connected, the rig can be pulled into position directly over the deck. They pull the rig inch by inch towards the guideposts, which mark exactly where the rig needs to be positioned.
So the rig is almost in position and the loadmaster is checking the mark against the mark on the guidepost to match each other.
It is the critical stage. When the Amethyst lifts the rig out of the water, even an inch off the mark could upset the weight distribution across the deck and destabilize the entire ship.
Additional lines are to be connected to make sure the final position is achieved.
They get it close, but not close enough. One final effort is all it needs.
Final position is in progress now. So the marker is across the marker on the guidepost, and we consider it is in position and start deballasting now.
In order to re-emerge from under the water, it has to shift out 100,000 tons of water from its tanks. It has to do so quickly, which is pretty amazing.
The ship is now ready to lift itself and 13,500 tons of oil rig right out of the water. It's the moment of truth. In the Gulf of Mexico, the Amethyst is about to start the final and most hazardous stage of the loading operation. The rig is now in place over the submerged deck. They can start bringing the ship up. Everybody's tense. The 13,500-ton rig is locked in position, but until it makes contact with the ship, it's still floating and unpredictable.
Because she's vulnerable for the whole process that she's ballasted down, Amethyst needs to move thousands and thousands of tons of water.
pumps with high-speed impeller blades use centrifugal force to fling water out of the tanks at an incredible rate of over 4 million gallons per hour. Instead of days, they can be emptied in 7 hours.
Pumps are big in order to have a bigger capacity. It is a bit noisy here.
As the ship starts to rise, when deck and rig meet, it's crunch time.
So a lot of factors can go wrong, and we should be ready for any of this. We are trying to do this, and until now we are managing that.
One of the riskiest points in the whole operation is as the ship lifts up and makes contact with the load. We have to be sure the load's in exactly the right place.
The pumps are so powerful, the sudden buoyancy has to be tightly controlled. Right now, if anything goes wrong, it will be a catastrophe.
If there's a problem with the ballasting system and the ship doesn't come up exactly as she was meant to, that could cause the ship to lose stability. That could result in her capsizing.
But the Amethyst can shift her own weight around to keep her balance. The pumps don't just move the water out of the tanks and back into the sea. They can also move water around the ship. However the load is sitting, Amethyst can shift her center of gravity to remain stable.
As it lifts up these giant oil rigs, it needs to be careful to keep the center of the weight in the center of the vessel. And so if the oil rigs are slightly off-center, slightly further forward or left or right, it can compensate by moving the water from one tank to another.
The ship keeps rising out of the water. Success. The Amethyst has loaded the first rig.
So we are safe.
The next day, the team need to repeat the process to get the second rig onto the deck. As the ship rises once more, the ballast team keep careful watch. Both rigs are out of the water and in the right place. Now the crew can weld them securely onto the deck before their long journey to Oman. At last, the Amethyst and her incredible 25,000-ton cargo are ready to set sail for the other side of the world. It's a job almost no other ship on Earth could do.
We consider that the loading operation has been completed.
From her incredible super strong deck to her super powerful propulsion system, from inch perfect positioning to her complex multi-tank ballast arrangement, she's one of heavy industry's greatest superstructures.
Amethyst is remarkable because they put all of these different technologies together to give a heavy lift ship that can do its job just about as perfectly as you can imagine.